Today I'm working on the V12 build again. So this is my one-off car that I'm building with the M120 V12. I've built cars and projects anyway, but this is my first one that I'm documenting and recording. I want to get these front frame rails finalised. So these are the ones off the donor vehicle. These are from the Mercedes. So the reason these are still here is they're holding the upper wishbone. I want to get them replaced with a nice drawn over mandrel seamless tube and get rid of some of this temporary structure. This front bar is also temporary. This is 6 litre with 400 horsepower. I'm going to be running the original Mercedes control system on this vehicle, at least at first, because I want it reliable. As anyone knows, that's pushed engines further. You end up chasing things around and another thing breaks, so I want to put some good miles on this thing. I may develop an engine that's going to be more powerful for this, still an M120 base block. I may swap it out at a later date. So by getting rid of these, it means I can get rid of these temporary supports. I want to try my windscreen surround, and then I can do the body, because the body's got to incorporate the windscreen surround. So I've already made that out of carbon fibre, and the body's going to be full carbon fibre, so it's all going to like join up to be one solid structure. We've got rubber mounts at the bottom, so I'm going to be keeping the rubber mounts. I can always replace them with polyurethane at a later date if I really want to. So this is going to be the driving position. It's very similar to the new Aston Martin, the Valhalla, where the feet are slightly raised. So this is because I'm using the original subframes. Dashboard's going to be about here, so it should work really well. As part of the testing, I need to have the dashboard quite low, otherwise I won't have enough viewing angle. It's going to be something like this, but I think it's going to work really nice, as long as I get the wheel small enough to work. I am planning to still use the Mercedes column, so I'm hoping to have that extension and adjustable height. Even though it adds a small amount of weight, I think it's going to be worth it. It allows me to fit different drivers in this thing, so I really want to use this car. For the same reason, I'm probably going to use the electric seat bases. I'm going to replace it with a lighter seat because the seats are very heavy. It's going to be worth it for that adjustment. The main reason is because I get height adjustment. In a lot of kit cars, you'll notice people tend to stack the seat up on blocks because you need to meet the regulations that say you can see at a certain angle. So if I make it height adjustable, it makes it easy. It makes it a lot more usable in the car. So I really want to keep them things if I can. I still think I can make the car under 1,100 kilos wet weight. Even with that, a lot of kit cars that don't have body are about 500–600 kilos. Similar to the new Aston Martin Valhalla, I'm going to have that kind of curve from the feet down to where the seat rails are going to be mounted, because the seat rails are going to be mounted quite low. This is going to have a carbon monocoque around here, so I'm going to make it out of sheet carbon and then layer up on top of it. So this is really just for torsional stiffness. These are doing all the structural work, and the carbon fibre will just be stopping the twist. So that's why there's no cross bracing on any of these tubes, because I want to use carbon fibre for all that. I want to make a seamless monocoque from the front where my feet are going to sit all the way to the back of the car, and it's probably going to come up to about this kind of height. At the back it'll come all the way up, but I'm also going to try and keep the sill quite low. You can see here I've got the original Mercedes subframe. Here's the adjusters for the wishbones, and here's the extra bar that I've welded in. So the curve here will make the interior nice, but it'll also mean from the underside I can still reach all of these adjustment points, which is what I need. I'm designing this to be used, to be worked on, to be easily serviced. For the same reason, I'm going to have part of a removable firewall so I can get to the engine, as well as I'm planning to make the engine slide back so I can access things really easily. If it ever did unfortunately break down, I can reach in and get to it fairly fast. The interior is actually quite roomy. It's 1.4 metres wide, so I've got a good bit of space. The whole car is going to be 2 metres, so this outside bit is more to do with the air that's been channeled around the front wishbones and into the rear radiator. I think it's going to work really well. Once I get rid of these bars, then I can try my window screens around. Then I can get a bit closer to starting the bodywork. I've already got the printout for the side of the car, so I'm going to use that to transfer onto polystyrene, make a whole book around the car. Once I've got these key things located, like the engine in the right place, the right height, then I can make the polystyrene book and lay up carbon fibre on top of that. So I'm going to be wet laying carbon fibre, which is still lighter than fiberglass, and the stiffness is the main reason I'm using carbon fibre. Some of these panels are 2 meters long by 2 meters wide, so I really want that stiffness, as well as it adds a nice element to it using carbon fibre. This is a dream build, so I want to make it really good. I know it doesn't look like much now, but I'm going to be machining a lot of the parts, a lot of the final parts, to make it really nice. If you're enjoying this video, give me a thumbs up. It takes a lot of work making these. So look at the front of the car, which is this way, to the front frame rail that I want to replace. My plan is to chop out some of this. I'm going to continue using this bushing, continue using this bottom piece of steel. It's a very good piece, it's nice and thick. So I want to chop this side off, weld the bar onto this base plate, come up, put a bend in, and then pick up the back plate of this upper wishbone, because I may as well reuse that. It's been tested, it's structural, it's got the threads to the right distances, so I may as well keep just this portion of plate and chop that out and re-weld it. So my new bar can come up, bend, and then come down here, be welded to this, and then we can reinforce it all. Then it'll come all the way back to a dash bar. I'm going to be putting plates at the far end where the dash bar is, where it meets the dash bar. So this allows me the ability to, if I ever need to shim it with like a 1mm shim or whatever I need, I can have some adjustability there. So let's get on with that. This is just rough measurement. I'm going to leave the pipe slightly long and then we'll chop them off. So we need about 900mm, so 90 centimetres, just under 3 foot. So the main thing is figuring out what this bend wants to be. I've got one of these cheap angle gauges, so I want this tube like this somehow to follow this angle, and I've also got twist where I can adjust where the end sits. So I want the end to sit pointed down at that. So from this rough measurement I'm getting something about 45 degrees. Now I'm going to bend the first tube, make sure it works on one side, then we'll duplicate it on the other side. So this is the tube bender I'm going to be using, just a basic hand press one. So I had race spec cages make most of the cage for me, do all the complex bends on their CNC bender. These small bits I'm going to do myself by hand. This is the tube that I'm using. This is 50mm 2-inch tube, seamless, sometimes called CDS. So it is a mild steel. It's easier to weld, it's easier to paint, easier to work with. So I'm just going to use this. Keeping it normal steel means it also has good crumple resistance. If the car ever gets crashed, it'll bend, it won't crack. The problem with some of the more special alloys is that they crack, they're more brittle tubes. That's why I'm using this. So next I'm going to chop it and then I'm going to give it a go, bending it. So I use a piece of paper. A piece of paper is one of the straightest things because they spend millions making sure that paper's absolutely perfectly straight and square from all the thousands of different printers that use A4 paper. Wrap it round so I can put a ring round that, and then that's where I chop. Okay, so that's a nice square cut on that tube. I'm going to give this a bend. So, I'm going to put the dies in the bender and we're going to give this a bend. I've got to line up my mark. Yeah, it's going to work well. So as I bend it, I can check the measurement, make sure it's nice and square, everything's set. There is going to be some spring back as well, so I need to overbend it slightly. The pipe is starting to buckle a little bit, so I'm just going to check it. You know, this is the 2-inch die, so really it shouldn't cause an issue. So something went wrong there clearly, because we've got massive buckling, even though that's the right size die. So I may have to change down to a different size. So it's the next day, as you may be able to tell. I've given it a good few goes trying to use this bender, but this bender's not suited well for this kind of thin tube. So the problem I'm getting is the buckling, which a lot of people probably know if you've ever had one of these kind of benders. They are known to buckle tubes. So I've tried all the tricks, I've filled them with sand. I've done that multiple times. I've capped both ends with steel plugs, and it's still bent. I've tried a mixture of duct tape on one side and capping it on the other. I've tamped it down, put an inch of sand in, tamped it, and another inch, tamped it, and kept going until it filled the whole tube, and still it's just buckling. I've tried different dies as well, because this first one that I used was too loose, even though it says 2-inch or 50mm. So, taking the next size down, I've even ground it to make it perfectly fitting at every single angle, and it's still buckling the tube. You can see I've had many attempts. This was a progressive bend, this worked a bit better, where you put a few small bends in instead of trying to do one big bend. So this is probably the best one I did, progressive bend. I did loads of small bends, every 5mm, but you can see still got this flat portion on top of the tube. The bottom doesn't look too bad, but the top's quite flat. So I would say to anyone looking to buy one of these kind of benders, if you're looking to do roll cage type stuff, I won't bother with this design. This design's flawed in the way it works, because it supports on both sides and then it puts a single point load in the middle. It inevitably always does that kind of kinking effect. So that's where your ram's pushing in the middle, because your tube only pushes the die right in the centre. So this means you always get that crumpling. I'm sure if you had solid pipe or something really thick wall, it may work, but ultimately this cheaper design style just is no good for this kind of stuff. So what's my plan now? Well, you can get different benders, which instead of bend on a point load, they do a rolling action, so they hold the pipe here and they pull it around like this. So that's ultimately what I want to make. I've got most of the components already here. So I've got most of the components already here to make one of them kind of benders, including the die is still handy and useful. So I'm going to have to rearrange some of these parts. I've still used the bottle jack, but instead of doing this point load type thing where you've got it pressing straight up, I'll have the die at an angle like this. I'll put it on the outside so I can show you. I'll have the die like this, have it so it can rotate, so the whole die can spin. The jack can be pressing on the bottom surface here, or some kind of linkage, and the flat bar will come all the way across the top into that. So when this is mounted on the inside, it'll be down the middle. I'll put a strap clamp over here, something like an exhaust clamp off the car will be strong enough. And then as you jack the bottle jack up, it'll rotate this part round, pulling the pipe round the die, as opposed to just bending it in the middle. That's my plan. I'm going to rearrange these parts and make this into a usable tool, and then we'll see if we can get these front sections bent. These pieces that I'm making now are also removable. They actually unbolt from the car, so if I'm not happy with them at a later stage, I can just change them anyway. So this is what I've done with the bender. I've rearranged it so now the die's here and it rotates around on the pin. So the way this works is that the pipe went through under this roller, under this strap, and then as the jack presses, it turns the pipe around. So I did manage to get a bend out of it, but I'm not quite happy with the quality due to the die. I originally thought the die could be usable, but the die is actually the wrong size, so that's part of the problem that I'm having, is that this thin wall tube
needs quite a wide bend radius. So the smaller die is too tight. This die is just the good radius, but it's too loose side to side. So I've tried to fill it out with material, make it really tight, fitting on the tube. But the only way I could make the finish on the inside was with the grinder, so it wasn't good enough. Managed to bend one, but it had little pits on the inside of the pipe. So what this is showing me is that the quality of the die is just really important to get a good bend. So I'm going to repurpose this for something else or reuse it. I'm not throwing it away. I don't like binning things. So I'm either going to make this into a press or maybe a pipe roller or something like that. But for now, I just want to crack on with the build. So I've got these two pipes bent up by the same people that made the cage. That's race mech cages. So of course these are nice perfect bends because they've been CNC mandrel bent, so it doesn't get any better than that. So I'm just going to use these and get on with the project. For any of the little bits, I think I'm just going to get them made because it's so much cheaper and so fast to get these things. It's not really worth messing about for now until I get built up with better tooling. Like that. So now I've got the pipe, I'm going to get this geometry set up so I can start chopping this away. So now I'm going to mark out where I need to cut. So I need to remove some more of this in order to get that tube a bit more downwards angle. It's about there. So I can see I've definitely got to take more out of here. That's all reinforced, as you may have seen. There's all sorts of corrugations in it. But I can cut this away because the car's quite well supported and this piece doesn't actually matter too much. I've got the wheel at perfectly vertical, so I can keep checking to make sure nothing moves. Although everything's adjustable anyway. So while I was cutting, I discovered the top layer was actually just a thin piece of metal. So I'm scrapping this and I'm going all the way down to the solid piece at the bottom, because this bit I want to preserve, this main post that goes down into the subframe. So I want to use this bottom plate, it'll be cut off there and across here. So this rectangle is the only bit that gets used. So the next thing I'm doing is putting a piece of steel on here to reinforce this, as well as give clearance so that my tube doesn't touch as it goes down, otherwise it'll be not even touching this piece. So that gives it the good backing, and I can weld all this together and really secure that. I can always add additional bracings on each side if needed. For now, I'm just going to tack this together. Now the tube should be able to sit flush against the piece of metal, which it does. So that gives me a good surface to weld down and really make a good strong weld down there. So now that I've prepped these surfaces, I can get this bar positioned. I need to really take my time to get the right cut on that bar so it matches this profile. I'm just going to cut a small amount off and then test fit and keep checking it. Right there is where it needs to be. So for the first cut, I'm going to leave it a bit longer because it's probably got to be chopped at an angle. So if I leave it long, I can see what needs to happen next and slowly dial this cut in. It's probably going to end up back here somewhere. So that looks to be like that. You can see we're quite a bit too long still. I can see now what angle that cut needs to be made on. So I'm going to keep trimming this off camera until I get it to fit. Then I'll come back and show you the final result and we'll get this welded in. So here's a finished tube. I've just got it tack welded in. So that's the front frame rails welded in. I'm going to leave them just tacked for now. I can focus on this rear dash bar. I can see if it's going to line up, make sure everything's looking quite square. I've got adjustability at every point, so if it is slightly out I can adjust, but I want to put it as square as possible first time. Before I weld the dash bar in, I want to make sure the windscreen height is going to work. So that's something I've got to check. So in order to do that, I need to take off the top of these towers where the damper bolts to, because this is going to be redone either in pipe or the damper is going to be relocated slightly differently, so I'm not too worried about the position of that. It's not as critical as the main suspension arms, the wishbones. The damper can be positioned in a lot of places as long as it meets that suspension travel. But I'm going to cut this cap in a way where I can reference it in case I need to see where the damper went. So this will get chopped around here, chop all that section off. When this is finished with the dash bar, I'll take this whole section off and chop from the backside and get rid of all this that we don't need anymore. So just have a nice plate on the bottom, and this section here, this bit will be able to go, so that'll be a lot of weight saving. So now you can see the upper wishbone exposed. On the Mercedes they actually use aluminium, even though it's a 2-ton car. So that's a really good sign for lightweight for my project. Because they put a lot of electronics in the Mercedes, they had to lighten up other areas. So the seats and everything are really heavy, because they've got 6 motors each. So all the other spots have to be quite light. So a lot of this suspension on this car is really well set up and quite light, that's why I'm keeping it. So you can see the upper board joint here. This is double wishbones, you've got one here, the other one down here which is steel. This is where the spring presses against. So that's both towers now cut off. So I've just cleaned these arms up. They were all greasy from many years of grind. So now you can see just how nice they are. Solid aluminium, really lightweight, quite thin. Going to be great for this build. Here's the windscreen surround. This is made of carbon fibre that I've laid over a Lotus Elise front windscreen, because when you build your own car you need to use safety glass, so I chose that as the vehicle to use because it's got a nice curvature and a good wide cabin. So the cabin's going to be 1.4 metres wide, which is quite roomy. On the Lotus Elise you normally have quite a fat door bar there, but on mine you won't, so you can have the full width. It only weighs 1 kilo, which means I can lift it with one finger, even my little finger. And I've also used foam to make a channel around it, so that this piece would have a channel to sit glue in. So this is in quite rough shape at the moment. I've not trimmed it yet, so it still needs trimming around all these pieces and smoothing off. This is more just for structure. It's not going to be seen on the final car, but leaving it rough means that my carbon body will attach to it quite nice, and it'll all lock in, because it needs something to grip onto it. If it was perfectly smooth, it wouldn't attach very well. This is the first time I'm going to try this out. I've been really keen to try it, but I couldn't try it until them towers have gone, so it's quite exciting to properly see how it's going to be. See if the cage fits quite nice. I'm expecting it to sit slightly high, the cage, because I'm going to do the roof curved to give more headspace, but I'm hoping these sidebars line up good. So let's find out. That actually looks like it's going to fit really well. because it was quite difficult designing this cage because I designed it in Fusion 360. I had to get all the angles correct. So before I made the cage, I made a plastic cage and just sat in it as like a mock-up and got the rough angles, measured the angles, transferred that to Fusion 360, got it as precise as I can. And then of course I've been CNC mantle bent, so the main thing was for me was getting them A-pillars really tight because I didn't want really fat A-pillars, I wanted skinny A-pillars on this thing. So it looks like it's going to line up really well. The bottom A-pillar is slightly wider, top's a bit thinner. So I'm just going to prop it up with some foam at the moment, just so it stays in place. And I can have a look, step back and have a look at it. So that's looking really good. I need to obviously clear up some of this a bit more to make sure we've got room for suspension to be looking down. So I think it's actually going to go maybe a little bit further back like that, where it fits really quite well. Of course 2 inches here is actually probably 3 or 3.5 inches here. So for now I'm just going to leave it just here. It's just sat slightly above the suspension. It's maybe about 1.5 inches or 40mm clearance here. So it's going to have more suspension travel than that. It may have like this much, but it needs to slide back slightly and I need to cut more away to get it to fit all the way properly. So the shape here has actually worked out quite good because the roof's going to come up and over. So you can see this can actually go down slightly. Even though this bar is slightly higher, this angle that the screen's already on is going to continue smoothly over the top instead of going up and then just going like that one. So now get a good idea of how it's going to look from the inside. Looks like they're quite good really. This isn't all the way back, but we're really tight on the top. Got a bit more at the bottom, but that's to be expected because it is angled and you're going to get some kind of triangulation there. So that's where the wing mirror is going to attach onto this portion of the door, this little triangle. So that's looking really good. It's good to start seeing it come together and shape up. It looks like I'm going to get a good height with the dash. The car only sits 4 inches off the ground or 100mm, so I'm not going to have that much suspension anyway. So at most I'm only going to have that much suspension. So otherwise the bottom of the car is going to bottom out and scrape on the ground. I've made the car quite low, but I've kept it high enough that it can drive over a brick. If there's like a house brick in the middle of the road, it can drive over it and it won't hit it. It's not tall enough. So it's got a good chance of being able to drive over a lot of things just on the off chance. Our roads aren't the best, they're quite potholed, so I want to make this quite a usable suspension, but it's not going to have that much travel in it. But I've kept the rubber joints just to give it a bit extra compliance to make sure it can ride the bumps nicely. I'm also going to have suspension lift on this, so for speed bumps it is going to raise up higher, so that's fine because when it raises up the wishbone's actually going to drop, so it's going to get more clearance. So I've only got to worry about the highest point where this arm wants to touch the surround. That's the point that I've got to worry about. But because the way the leverage works, this is quite close to the pivot, whereas this is quite far away, so in actuality this is going to be up here before it even touches, and this is going to be slightly further backhand up as well, so I'm not worried about that. You can see how these bars maintain the interior space quite well. So this is the foot position. I'm going to have an extra metre in front of this windscreen bar, so that's going to be for storage of luggage and things like that. I've not put the radiators in the front, I've put them at the back on each side. So either side of the cabin there's going to be airflow. That's going to cool the engine. So I want to make this quite usable, that's why I've maintained a good size trunk or boot. So I want to take some road trips and take it to Italy and do things with it. So the main purpose of this is just to find the height of that dash bar. So this is the diagram that I'm using to get the dash bar in the right place. This is from the IVA manual, the individual vehicle assessment in the UK. So it's the same in most countries, very similar rule sets. But you can see here, this needs to sit on top of my seat. This represents the backrest of the seat, and you can see the angles that they specify in the diagram, the point where you need to be able to see downwards, so all the bodywork needs to be below that line. Then that's where my dash bar needs to be. It needs to be either there or below. My dash bar's up here, then it'll fail the test and I won't be able to use it on the road. So that's why I've drawn this out. So now I'm going to set up my diagram on the inside. This piece here is going to be chopped off where the dash bar goes across, but I first need to verify the height before I make the chop. So I need to measure how high the seat's going to sit. I'm using these big chunks of steel just to get the seat at the right height. So that's where the rails are going to be sat on top of. So now I'm going to build up the stack height to get to the same height that the seat would be, so I can check the diagram as well as maybe sit in the car after. So this is the same height as the Mercedes seat base. There's a little bit of height there compared to a normal rail that only goes back and forth, but this also has adjustable height, so that's why I'm using the Mercedes base. So that's the overall seat height if I use the seats that I think I'm going to use. So it's actually not as bad as I thought. I'm sitting at a decent height. So that's going to be too high. Definitely need to take some height out of it somehow. So either mounting the base lower or changing seat type. This is about the ideal height, because the roof's going to come up slightly anyway. So it's going to flow like this. That's about where I want to be. So I think I need to adjust the height or something to ensure that I get this height. This height would also make for quite good visibility. Now I've got the actual Mercedes seat base in for testing, so I can see what seats I can use. I can have adjustable height, which is one of the things in kit cars and small cars with rails. It's sometimes annoying. You feel like you're sitting too low or too high. So this is going to be a good addition. So I'm going to use some of my weight allowance and keep this system and just change the seat to whatever we need to use. If I have to use a lighter seat, then we'll go that route. I'd love to make my own seat, but I don't think it'd be compliant, so I'm going to use something pre-made. Okay, so even this is too high, so I'm going to have to mount the seat even lower down. This bar's going to go, it's going to be replaced with another bar that's going to come up and bend. So there is going to be more headroom than this. The bar's going to be about here. I'm going to have carbon fibre surrounding the bar to make a nice opening. I am planning to make this a removable roof section as well, but pretty flat so it can go behind the seats. So I think being 30mm lower would really help. Now I'm going to try putting this in. So this represents if I use a really thin seat and then added my own padding. Oh, that's better already. Much better. I can't sit far enough that way yet because I don't want to squash electronics on the seat, the connectors. But by the time I lean back slightly, like this, that is going to be perfect height, that is. So that's really where I want to be. So I'm going to have to either move the seat down or use a really thin seat, the kind of carbon fibre or fiberglass looking ones, and just add my own padding, get it properly upholstered and add some Alcantara pads on there. It'll also offset the weight of the base quite nicely. So I want something Alcantara nice looking, but it's got to be a bit comfy as well, because I want to do road trips. I don't really want to lower
the seat base any further, because then I can use some steel channel to join the sides together. So the bolt comes through and sits in the channel. It means I don't have to chop the bolts down, so I've got adjustment there. I think that's going to be the way to go. So I'm going to test it now with this seat height. I'm going to see if it works. Another thing I'm also going to test is how easy it is to get in the car. Obviously this bar's in the way, which won't be, but I'm going to have true scissor doors that go straight up. This is mainly for convenience, parking next to other cars, because in England our roads are quite small and our parking spaces aren't that big. So anyone that has a wide car like a Lamborghini Aventador, you do struggle if you ever go anywhere and park next to people. So if I do scissor doors, it eliminates that problem, and it also adds a nice flair to the car. So I'm not doing any kind of silly outwards and up kind of style doors. I want true scissor doors. So I'm going to be machining my own bracket with bearings. So it's a big billet piece of hinge that hinges the door upwards. So let's give this a go. I'll be getting in something like this. I think that works quite well. The seat height. Whereas if you open the door, the floor's not too low. The floor's just there. I think this is going to be a good position. It also means my feet aren't as high as the floor. My feet are actually still slightly lower than where I'm sitting. It's almost a level position. And then we're still going to have the carbon coming down and going under the seat base here, so I'm still going to have the curve. And then the door sill, I can make a carbon cover that comes maybe to here, so I don't have to have a high sill. Yeah, let's go with this. So now I need to set up a string line across where I think the dash bar's going. I'm using this blue rope, which isn't the best because it doesn't stretch, so it will sag slightly, but it shows up good on camera. And as long as I'm well above this, we're all good. Now I'm going to get this really tight. That's a perfect string line at the same height as the top of these and in line with the uprights of the 8 pillars. So here's the diagram showing the visibility. So this is like the back of a passenger. That line's the seat. This line represents the width of your body, so that's like your centre line of your body. This, what they reckon, is the average head angle. So bodywork needs to be below this 5%. So you can see it is just under there. I've got good clearance to this bar. The front of the carbon fibre is about there, so you can see I've got a bit of space there as well. You can see we've got a lot of space to this dash bar, which is good, what I want, because I'm still going to have the foam and the dashboard itself, whatever else I want on there. So now I know the dash bar's going to work, I can get on fabricating that. I've just chopped these pieces off the ends, ready for the dash bar. I'm going to have plates joining this bit to the dash bar, so I'm going to have a plate on the dash bar, plate on that, and then bolts going through. I've left these a bit long at the moment because I've not got the plates yet. Now I've chopped these off, I can get better access to make a nice cut on each side.
here's the dash bar that I've just made. It's the last piece, so hopefully it fits. There we go. Wow, first try. I'm very surprised. I thought I'd have to grind some off each side. That's pretty tight, that'll always hold itself. So there's no side to side wiggle, so that's perfect. I'm going to put some clamps on this just to hold it in place. So like I said, I'm going to have plates at these points so I can shim it as well as remove these front arms if I ever need to. It's also good because it means if the front of the car's ever crashed, the whole chassis doesn't get written off. So that's why I've done it this way. So I still need to make these plates, but I'm not going to rush that just for the video. I'm going to make sure I do it properly how it needs to be done. I'm thinking I'm going to do 2 M16 bolts on each side and make some spacers like I did for the rear, some solid steel spacers to really capture that, as well as I want to do some kind of bracing to this side bar so that all the load's not just on this one piece of bar. I want to tie it in somehow. I may even do a tie from the inside edge from this point back to this post lower down. Once this section's gone, might put an adjustable link in just to give it that extra strength. I've got M16s at the bottom, I'll have M16s at the top, and then if I have some tie rods, then that means the whole thing's adjustable but also solid. As well as there's going to be the carbon fibre tub, which is going to link and support onto this. So the carbon tub is also going to help give structure to these bars. Carbon's going to be all the way under here and like glue in. So it's going to be absolutely solid like a boat hull. So that's going to be at least 3mm thick of solid carbon. Some places it's going to be Kevlar, other places it's going to be extra reinforcement. I've also seen another channel use titanium as an under tray to stop things from puncturing through. So I may actually use titanium for the bottom. So this has worked out really well. It's come out better than I thought. There's only one last thing to do. There's the windscreen surround in its position. Now it's really starting to come together. It's really starting to look like something. So this is the view from the passenger seat. It's going to be quite a nice place to be. So this is where I'm going to leave the fabrication for today. It's been quite a lot of recording, a lot of grinding, cutting, chopping, all sorts. So it's looking really good. I'm really pleased to see it start to come together. It's starting to look more like a car again now. Just having this one piece on really shapes the front end. Gives you a bit of an idea of how it's going to be. And then the wheel arches are going to come quite close. And then it's going to come down like this to about here. So it's going to have quite a good size trunk in the front, about 1/2 metre by 1 metre. And get all the space for that stuff. And I'm planning to put the battery probably in this area here to try and keep more weight over the front end, because the rear's going to be obviously quite heavy. So I believe the Zonda has a 40-60 weight split, so I'm aiming for something very similar. 50-50 isn't actually always the best thing. It's not always the perfect thing for a mid-engine car. Sometimes it can cause the car to spin. It can make it more unstable, so there's all different thoughts on that over where the position should be. But clearly I'm going to have more weight in the rear because it's a 315 kg engine and it's not going to be too much up front. I'm going to try and put a lot of the electronics up front, like the battery, the vacuum pump for the doors, the vacuum pump for central locking. So I'm keeping them because they only weigh like 3 kilos, so it's worth having. I can have soft closed doors. So the doors are going to be carbon, so you don't want to really slam them. It'd be nice if they can just pull down and close. So I'm going to do soft close latches on the doors as well as the front and rear, like boot, bonnet, engine cover or front bonnet. I'm going to have 2 latches on it and it's going to be quite a big piece. It's going to be massive boot, so when I close it, it'd be nice if it just latches by itself. I don't have to like slam it down or do anything weird. That's the plan. So this front's going to open this way and the rear engine cover is going to open that way like a Koenigsegg or an F50 or a Ferrari F40. It's going to open to expose the whole rear engine of the car. I'd like to, next episode, probably do some work on the rear, start getting that engine mounted, but I really want to get this thing progressed this year. If you're enjoying this, give me a thumbs up. It takes a lot of work making these and it just keeps me going with the next stages of recording. Thank you. I'm aiming for a high quality build, something like Pagani or Koenigsegg level, but I'm only making one, so this is my one of my dream builds, so that's what this channel is going to be. I'm going to be building my dream cars. That's what I was already doing, but this is the first one I'm documenting, so we'll see how it goes. If people enjoy it, I've got a lot of other really cool projects that I could share, so keep giving me thumbs up, keep commenting, give me positive feedback, and I'll keep putting the effort to record these videos. It's going to be quite cool.